Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman and my matric number is B1323100067.
My name is FAROUQ bin SULEIMAN. My matric card number B1323100143.
My name is LUQMAN HAQIM bin Muhammad SHARIF BUDIN. My matric number B1323100099.
My name is Muhammad IQBAL bin Muhammad RAZAHA. My matric card is B1323100006.
Result. Table 1 assign material properties of this brake rotor. Number 1, properties Young modulus. Value 2E plus 011 unit Newton meter square. Number 2, Poisson ratio. Value 0.266 Newton meter square. Number 3, properties density. Value 7860 kg per meter cube. Number 4, thermal expansion value 1.17 E minus 0.005 Kelvin per degree. Number 5, yield strength 2.5 E plus 0.08 Newton meter square. Table 2, assign material properties of disc brake rotor. Ventilated disc brake. Number 1, load 2346 Newton. Outcome maximum von Mises stress. Value 7.851 E plus 0.7 unit Newton meter square. Minimum von Mises stress 4.0373 E plus 0.2 Newton meter square. Translational displacement 6.211 E minus 0.2 mm. Number 2, load 2680 Newton. Maximum von Mises stress. Value 8.969 E plus 0.7 Newton meter square. Minimum von Mises stress 4.653 E plus 0.2 Newton meter square. Translational displacement 7.095 E minus 0.2 mm. Number 3, 3000 load Newton. Maximum von Mises stress. Value 1.004 E plus 0.7 Newton meter square. Minimum von Mises stress 5.209 E plus 0.2 Newton meter square. Translational displacement 7.942 E minus 0.2 mm. For solid disc brake, number 1, load 2346 Newton. Outcome maximum von Mises stress. Value 6.012 E plus 0.5 Newton meter square. Minimum von Mises stress 1.536 E plus 0.2 Newton meter square. Translational displacement 6.481 E minus 0.4 mm. For number 2, load 2680 maximum von Mises stress 6.868 E plus 0.5 Newton meter square. Minimum von Mises stress 1.755 E plus 0.2 Newton meter square. Translational displacement 7.404 E minus 0.4 mm. Number 3, load 3000 Newton. Maximum von Mises stress 7.688 E plus 0.5 Newton meter square. Minimum von Mises stress 1.695 E plus 0.2 Newton meter square. Translational displacement 8.288 E minus 0.4 mm. Calculate the safety factor. Ventilated disc brake. Number 1, load 2346 Newton. Safety factor 2.5 times 10 the power of 8 divided 7.581 times 10 the power of 7 equal 3.3. Number 2, 2680 safety factor 2.5 times 10 the power of 8 divided 8.696 times 10 the power of 7 equal 2.9. 3. Load 3000 Newton, 2.5 times 10 the power of 8 divided 1.004 times 10 the power of 7 equal 2.4. Solid disc brake. Number 1, load to 2346 Newton. Safety factor 2.5 times 10 the power of 8 divided 6.012 times 10 the power of 7 equal 4.15. Number 2, load 2680. Safety factor 2.5 times 10 the power of 8 divided 6.868 times 10 the power of 7 equal 3.6. Number 3, load 3000 Newton. Safety factor 2.5 times 10 the power of 8 divided 7.688 times 10 the power of 7 equal to 3.25.
Result comparison for safety factor for different track geometry. Okay, it have a three aspect: structure strength, thermal performance, weight, design complexity. Okay, for the structure strength for ventilated disc, it's lower safety factor due to reduced material volume. For the solid disc, higher safety factor due to more uniform geometry. Okay, for the thermal performance, ventilated disc is better heat dissipation, and for the solid disc, poor cooling capability. Okay, for the weight, for the ventilated disc is more light than solid disc, which is more heavier. Okay, design complexity for the ventilated disc is more complex geometry, and for the solid disc, simple design. Alright, result for ventilated disc brake 1 meter stress. Okay, the load we put 2346. Okay, this slide show the stress distribution on the ventilated disc brake when a load of 3046 Newton is applied. What we can see that the stress is concentrated mainly around the contact and inner region of the disc. Okay, this is because the disc has ventilation holes. Some area experience higher stress compared to a solid disc. Alright, this slide show the displacement of the ventilated disc brake at 2346 newtons. Alright, the displacement indicate how much the disc move or deforms under the applied load. Okay, at this load, the deformation is relatively small, showing that the disc is stable and safe. Alright, for second load, 2680 for 1 meter stress. Okay, we can observe that the stress level increased compared to the previous load. The stress concentration become more visible around the weighted areas. Okay, it's showing how the remove material affects strength. Okay, alright. For the displacement for load 2680. Okay, the displacement is higher than before, which is expected because the applied load is higher. However, the deformation is still within acceptable limits.
Okay, ventilated disc brake with load 3000. At this load, the stress is significantly higher and more concentrated. This is help us understand the maximum stress this the disc can experience during heavy braking. Okay, displacement. Here we see the displacement of ventilated disc brake at 3000 Newton. The deformation is higher among the ventilated disc case. This show how the disc behave under extreme loading condition. Okay, now we move to solid disc brake von Mestres. with load 2046 Newton. Uh, Compare the ventilated disc, the stress is more evenly distributed. This is because solid disc has no hole, will help it handle static load better. Alright, for displacement, this slide show the displacement of the solid brake at 2346 Newton. The deformation is lower compared to the ventilated disc at the same load. This indicate higher stiffness and structure strength.
Okay, for the next slide is solid disc brake, that is bond mixture stress. So the load that we apply is 2680 Newton. So in this slide, the solid disc is analyzed under a higher load of 2680 newtons. So the stress increase, but it remains the more evenly spread across the disc surface. So this is shows the solid disc ability to resist the stress evenly. Okay, this slide show the displacement of the solid disc brake at load 2680 newtons. Although the deformation increase with load, it is still less than the ventilated disc. This confirm the solid disc higher resistance to deformation, as you can see at the picture that we insert. Okay, next for this slide, present the solid disc brake under the maximum load of 3000 newtons. The stress level is high, but it is distribute more uniformly compared to the ventilated disc. This explains why the solid disc has a higher safety factor under the static load. Okay, for this final slide, in the section show the displacement of the solid disc disc brake, that we put the load at 3000 newtons. Even at the maximum load, the deformation remains controlled. Because this demonstrates that the solid disc brake is structurally strong under the static conditions.
Discussion for solid disc brake between ventilated disc brake. In simple terms, the solid disc is strong under static loss because its solid shape spread stress evenly, giving a higher safety factor, while the ventilated disc show higher stress due to material removed from vent. However, in real brake condition, the ventilated disc perform better because it dissipate heat more effectively, reduce braking fade and thermal damage. So its lower static safety factor is an acceptable trade-off for better overall performance and durability.
Conclusion. In summary, solid disc brakes are structurally stronger under simple static loads, but ventilated disc brakes perform better in real driving because their vented design disperse heat and reduce brake fade. Although ventilated discs may show lower static safety factors, their superior thermal performance make them safer and more durable for everyday and high demand use. Any irregular results such as the anomaly in load 3 should be rechecked to ensure the analysis is accurate and reliable.